Thank you very much. So first I want to say thank you to the program committee for inviting me. It's a great honor, and thank you all for coming. I know it's been a long day. So that was a great introduction, and some of the things some of the points I was going to make have already been made. So because I'm teaching technical subjects, you know, I've always used multiple choice tests. All my colleagues use multiple choice tests. So just for a show of hands, if you're currently using multiple choice tests in your teaching, put your hand up. Okay, great. So it's something we kind of take for granted, and maybe you're wondering, how can I give a talk or do research in multiple choice tests? It's such a standard thing. But I hope that I'll be able to make you think about some issues which maybe you haven't thought about before. So I'm going to talk about what we use multiple choice questions for, so formative and summative, and the problem of guesswork. So that's really the crux of what I'm going to be talking about, is the problem of guesswork and what can we do about reducing guesswork in multiple choice tests. And that's one of the main reasons I think multiple choice tests have a bad name, you know, don't have a great reputation, because people know that students are going to guess and that the scores are unreliable due to guesswork. So I'm going to talk about how to reduce guesswork, and also a study that we've undertaken at London South Bank with a novel multiple choice testing method, which we're really happy about, and we're now using as a standard method for all of our first year students. And I'll show you some demo tests as well. All right. So I'm sure you all know what multiple choice question is, but I'm going to be talking about questions only with 4 answers. Okay, so a question and 4 answers, only one of the answers is right. And as Susan said, it's hard to create good questions. Many of you are using multiple choice tests, so I'm sure that you know. I mean, if you're teaching maths, so I teach maths, and maths it's easier because you can have the same question and you just put different numbers in, so it's quite easy. But if you're teaching computer architecture, which I teach, or internet technologies, or lots of other subjects, where your questions have got to be testing understanding or testing knowledge, it's not so easy to create good questions. Okay, so that's what a question looks like. And of course you can, another reason, you know, some people think, well, multiple choice tests only test quite superficial knowledge, it's just knowledge recall, but that's not true. You can design questions that really test understanding. So here's a question. You could imagine 4 answers, A, B, C, D, and each of those A, B, C, D was a different chess move, and here you're assessing somebody's, you know, how good they are at chess by saying which of these 4 moves will guarantee checkmate in 3 moves. Okay? Or we teach programming to students, so we can give a little program and we can say, after this little program has run, what's the value of x? A, B, C, D. Okay? So there's many ways that you can write questions to really test understanding, not only knowledge recall. Sorry, that was the wrong button. Okay, so we use multiple choice questions in 3 ways, really. So we're now in the habit, or for some of the things we teach, at the start of a lecture, and particularly a 9 o'clock lecture when some students are coming in a bit late, we use an online system called Kahoot, which is a free system. And there you create the quiz in advance, so maybe 10 questions or 12 questions, and then when you start playing it, it shows a code number, and the students need to go on their laptop or their phone to kahoot.it, which is a website. They put in the code number, and they've got then access to that quiz. And then you wait a little while till everyone's logged in. And people have to put in a name, so students who are quite confident maybe put their own names, other students put in silly names, so they kind of maintain their anonymity. And then you play the quiz, and then it's really engaging. We find the students really like this, and it's refreshing their knowledge from the previous week, and some students are doing very well on this quiz, other students are aren't doing very well, but at least they're learning, finding out what the right answers are if they have no idea. So we find that a really engaging way, and it's a real game. And then at the end, there's a winner, and it kind of shows who is the person who is the winner. So that's one way we use these questions. Another way is we provide self-learning tests, so answer until correct quizzes. So I can show you a demo of that later. So these are questions that students are answering in their own time, and they're finding out what the right answers are, so they're practice quizzes. And then, of course, we use quizzes for assessment as well. Right, one thing we do is to, at the bottom here, so we use PowerPoint for multiple choice question creation, sharing, archiving. Right, so we're using PowerPoint. So each slide is a question. So if I go on to the next, so here was that question I had at the beginning about spiders, okay? It's a PowerPoint slide. So the idea is that in the PowerPoint slide, you put the question and the 4 answers. So that way your archive of questions is a PowerPoint document. Actually 2 documents, because one document just has the questions, and the other document has the answers marked in it. And that's great if you're working collaboratively with other teachers. You can share those PowerPoint documents, and other people can add to them or comment on them. Okay, it's great for working as a team. And then when you're using, depending on what kind of VLE you're using, we use Google Forms. I'll show you a Google Form in a minute. This makes it easier to create the questions online. Let me show you the Google Form now. Okay, so I've got that already set up here. Right, so I don't know if you're familiar with Google Forms, but, what's happened there? Thank you very much. Not sure what I did there. Thank you very much. Okay, so here's the Google form. Right. So we've got this question bank of questions as PowerPoint slides. And creating a test on Google is really easy because you have a template test with say, 20 questions. Okay? And each question is just the PowerPoint slide or the image. From a PowerPoint slide, you can save it as images. So you then save 20 images. And it's just a question of putting image 1, question 1, image 2, question 2, image 3, question 3. Can you see? And the answers are just A, B, C, D. You don't need to type in the answers because normally when you're creating multiple choice tests using a VLE of some kind, you type in the question, maybe you upload an image, you type in each answer, then you're identifying which is the right answer. Okay, so there's quite a lot of work that people put into creating the test online. And also, once the test is online, you don't kind of have it, you don't own it in the same way. Maybe you own it as a Word document or something. But I hope you can see how this makes just the test creation process a lot smoother, a lot easier. While I'm here, I can just show you different kinds of questions. So here's a question with 4 images. Which of these images is correct? And that's great, let's say, for medical questions. We've got a school of nursing, for example. And you could have 4 X-rays or 4 images of MRI scans or whatever. And which image shows a particular problem that you're trying to educate the nurses to learn about. You can be creative in terms of, okay, so here's a question, and the 4 answers are there, A, B, C, D, they're hotspots within the image, right? Okay. So I'll come back to this later because it's a subset selection test, which I'm going to explain a bit later. Right. So now on to the guesswork. So I've told you how we use multiple choice questions, and I've told you that we archive our questions and we share our questions in the form of PowerPoint documents. Okay, now the problem of guesswork. So, if you have a standard multiple choice test with every question has 4 answers, so here's score versus knowledge, okay? A good test should have a profile like that, okay? So a student who has 0 knowledge should score 0. But for multiple choice tests, because of the guesswork, students who know nothing, on average, they're going to score 25% through blind guesswork. Okay, here's another way of looking at that. If you've got a question, a test consisting of 50 questions, right, or maybe 2 tests of 25 questions each, so there might be 10 questions. So here there are 10 questions that the students know the right answer to. And so 10 out of 50 is 20%, so they get 20% of the marks. Here are 40 questions. Let's say the student has no idea, and so they're guessing. So on average, they're going to get 1 out of every 4 right, so they're going to get 10 out of these 40 right. So they got another 10 questions right through guesswork. So they got the 10 questions which they knew, plus the 10 questions which they guessed on average. Okay? That gives them 20 questions out of 50, and that's 40%. Okay? So they're getting a mark of 40%, which for us is a pass mark. That's a bare pass. So this is a scary thought. They're getting a bare pass by only knowing the right answer to 20% of the questions. Okay? So that's the problem. Okay, but that way of thinking kind of assumes or makes it sound as if students either know the right answer to a question or they've got no idea and they're going to be blind guessing. But in fact, students are often making educated guesses because they can spot 1 or 2 wrong answers. Okay? So if you think of the spider question, okay, spiders have 4 wings, 6 legs, 8 eyes, 10 ears, right? So maybe most people in this room would know that spiders don't have wings and they don't have 6 legs, they've got 8 legs, right? But 8 eyes or 10 ears, maybe people are not sure. So if you can narrow it down to a choice of 2, you're making an educated guess now. But with a traditional test, you're being forced to guess. You have to make a guess between those 2, right? And you might be lucky and you might be unlucky. So there's still guesswork going on because of the educated guesses. So a more accurate picture is to say there's some questions that the students know the right answer to. There's some questions at the bottom which students have got no idea, so all they can do is make a blind guess. But there's some other questions in the middle which students have got some partial knowledge and they can make some educated guesses. Okay, so this, bringing down the graph like this, okay. Negative marking, this is talking about negative marking. Maybe some of you use negative marking. I'm sure you know about it, but in case you don't. The idea with negative marking is that we award 3 marks. If a student gets the right answer, they got 3 marks. If they guess a wrong answer, it's -1. So if they're guessing over many questions, the negative marks will cancel out the positive marks. Okay, so it's +3, -1. And that has the effect of bringing down the line. And it does 2 things. One is it compensates for the guesswork, because if you assume that students are guessing, you're sort of penalizing them when they make wrong guesses. But the other thing you're doing is you're discouraging blind guessing, because if students know that by making a blind guess, they've just got just as much chance of increasing their score or decreasing their score. Maybe some students are going to be put off making blind guesses. Okay? But they still should make educated guesses, because it's still in their interest to make an educated guess. Okay. Right, so just to remind you, a good test has a profile like this, the knowledge versus the score. Right, with a traditional multiple choice question, if we just look at one question, we can now, instead of knowledge, we can look at the distractors identified. So with 4 answers, a distractor is a wrong answer. So there are 3 wrong answers. So if a student can identify 3 wrong answers, they get 1 mark. If they can identify 2 wrong answers, then they have to make a choice between those 2. On average, they're going to get half a mark. Okay? If they can identify 1 wrong answer, they're having to make a choice between 3. On average, they're getting a third of a mark. If they know nothing, on average, they're going to get 0.25 if we have no negative marking. Okay, if we introduce the negative marking, so +3, -1, so the idea of that is really for these students. We're trying to get these students down to 0. We're trying to penalize them by saying, no, you shouldn't blind guess. But in the process of doing that, we've also penalized the students who have some partial knowledge. Okay, so this student who can identify 2 distractors, this student has got a 50-50 chance of getting 3 marks or -1 mark. Okay, so it's quite a harsh penalization. Okay, but what we could do instead is to... Okay, this was an idea that I had in the late 90s, but it turned out that other people had had this idea long before, which is no surprise because it's quite an obvious idea really, but subset selection, maybe some of you are familiar with it. So the idea is that you award 3 marks for the right answer and -1 for a wrong answer, okay? But now we can allow students to select more than one answer. So if a student thinks the answer is this one or this one, we can allow them to tick both. And if the right answer is one of those 2, they'll get +3 marks for the answer that is right and -1 for the one that was wrong, so they're going to get 2 marks out of 3. So that's actually quite generous. 2 marks out of 3 is generous if they can identify 2 distractors. Okay? If they can identify 1 distractor, they're getting 1 mark out of 3 because that says they're getting +3, -1, -1. So they're getting 1 mark out of 3. Okay, so that was the test format that we used for many years. And that works on paper. It's very nice on paper because you're giving students a multiple choice test on paper and you're saying to the students, you can select more than 1 answer per question. Okay? And marking it on paper is quite easy because it's quite easy to calculate, do they score 3 or 2 or 1 or 0? Sometimes you get negative scores. So if a student thinks the right answer is this one or this one, they tick them both. And if they're both wrong, they're going to get -1 and -1. They're going to get -2 for a question. So lots of students, as you can imagine, were very unhappy about that. So the students, when they saw that they were getting penalized for wrong guesses, they were actually getting minus marks. Every year, we had some students complaining about this test format, thinking it's not fair. And also, some colleagues were put off using this because they felt it's unfair because of these negative marks. But nevertheless, we persevered with that. Okay, there's further information about that in that paper if you want to follow that up. Okay. But then, later on, we realized that we could still have subset selection, but without the negative marking. Okay? So, subset selection without the negative marking. That's what we've been using for the last about 5 years, and that's much smoother. The students are much happier about it. We don't get any complaints. Staff are much happier about it. Okay? So, let me explain this one to you. Here's the question. Here are the 4 answers. This is also how we explain it to the students. Okay? And of course, you have to spend quite a bit of time explaining it to the students and giving them practice tests so they really understand it before you give them the first summative assessment. So, here's the question. Here are the 4 answers. Okay, if you think the right answer is that one or that one, and you tick them both, and one of those 2 is the right answer, what mark do you think you deserve? Okay? And many students will say, okay, I think I deserve half a mark, which is what the system will give them. So we've written some software to do this. The system will give them half a mark, okay? Because if they had a traditional test, they're forced to be making a guess between this one and this one, right? On average, they're going to get it right one in every two. They're going to get 0.5 on average. So what our system does is say, don't make a guess. The system will give you 0.5. Okay, just be honest about the fact that you're not sure which of those two it is. Or alternatively, if you think it's one of those three, tick all three. Okay, what mark do you think you deserve? Many students will say a third because they've got a 1 in 3 chance. Okay, I hope everyone is understanding this, yeah? So we're saying that a student can spot one distractor, so they know it's not that answer, and they're not sure which one of those 3 answers it is. So we're saying select all 3 answers. You deserve, if one of those is the right answer, that means in a traditional test, if they couldn't decide which of those 3 it is, they'd be making a random guess. So there's a 1 in 3 chance they're going to get it right. Okay? So our system will give them 0.33. If they tick all those 3, the system will give them 0.33. Right. The harder one to get people to understand is to say, if the student has no idea, like spiders, a student doesn't know what a spider is, never seen a spider before. So rather than making a blind guess, okay, we say, leave it blank, don't answer at all, and the system will give you 0.25 of a mark, okay? Which sounds ridiculous, but if you don't do that, students are going to make a guess anyway, because if there's no negative marking, students are going to say, well, I don't know what the right answer is, but I'm going to make a guess because I've got a 1 in 4 chance of getting it right. Okay? So we want to inhibit them making a guess. That's the key point. We want to inhibit students from making guesses. We don't want students to make guesses, because when students make guesses, it means that the score is unreliable. It means that the score at the end of the test is partly what they deserve, and it's partly their luck. So if they took the test one day and they took the same test the next day, but they made different guesses, they would be getting a different mark. So that's, in that sense, unreliable. So by rewarding their partial knowledge explicitly, we're saying, don't make a guess, you just put what's in your mind, and the system will give you a score accordingly. Right, if I go to the, back to this, is it still there? Okay. So this is a Google form, right? And it's set up to be a subset selection form. So these are not radio buttons, okay? Normally you'd think, well, they're radio buttons. These are checkboxes. So I can select that one, and I can select that one, okay? And I don't know who's used Google Forms before. It's really easy to use. And every time a student submits the form, you get a new row in the spreadsheet. So there's a column in the spreadsheet for every question and a row in the spreadsheet for every student. Okay? And it records. So for that question, that student, A, comma, B. Right. So then you get a big spreadsheet at the end, which records all of the test responses from all of the students. Okay, and first of all, we were kind of marking that by hand, which was quite a time-consuming process. But last year, I wrote an Excel macro for it, so it now does the marking automatically. And I'm very happy to share that Excel macro with anybody. So if you would like that, email me. So that means you can. It's really easy to set up your test on Google Forms, and I recommend using PowerPoint, because it makes the test creation process easier. You get students to take the test, you end up with a big spreadsheet, you run the macro, it automatically marks everything. So that's now what we do in my department. Okay, if I go back to... How am I doing? Okay. So in 2013-14, we ran a study with our first-year students, and we made the students take a test twice, well, 2 tests. So the same set of questions. For each question, they had to answer it 2 different ways. Once was the traditional way, pick one of those 4, A, B, C, or D, and also answer the same question again, subset selection. You could tick more than one if you wanted. and we got all the students to do that, and then we analysed the results, and we asked them to fill in a questionnaire at the end to ask what did they feel about this. And there was quite a high preference for subset selection. So the students understood it, they liked it generally, and they found it was less stressful. They found it less stressful that they weren't forced to make a guess between alternatives when they really weren't sure which was the right one. They preferred being able to tick both. And also the Cronbach alpha score was better. So in other words, that's an indication of the reliability of the tests. So that means the subset selection tests were slightly more reliable than the traditional tests, okay? Which is kind of what we're expecting because less guesswork going on. Right. So I hope that you understood that. And I feel really positively about this now. I feel like, isn't that a better way of doing multiple choice testing? It's kind of unfamiliar, but you're still using the same question bank. So all the people who put their hand up, you're using multiple choice tests. You've got a question bank of multiple choice tests, okay, of multiple choice questions. You don't need to change those questions. All you're doing is changing what you ask the students to do. So now you're asking students to use subset selection. So my feeling is, why doesn't everyone use this now? So I'd be interested, if we got time for talking at the end, I'd be really interested to know how you feel about that. Okay, so now I'll talk about some other test formats which we're not using, but which I think in theory might be even better. So I think these slides are going to be available on the web, aren't they? I can see people taking pictures, but right. So traditional tests, we know what those are. Subset selection, I've just been explaining those. Right, order of preference, that's another thing which you could do. You could say, here's the question, here are the 4 answers. You could ask students to put them in order of preference. What's their first choice, second choice, third choice, fourth choice? Okay. And then they would get a mark, depending on, they'd get the top mark if the right answer was their first choice, but they'd also get some credit if the right answer was their second choice. Okay? But then, if the right answer is their third choice, or even worse, their fourth choice, well, then they need to suffer some kind of penalty for that. And the kinds of responses students can give here, they're being forced to put in an order, first choice, second choice, third choice, fourth choice, are very different to the kinds of responses here, because here you're saying students can identify a joint first choice. Okay? Here, there can't be a joint first choice. But on the other hand, with subset selection, students can't say that this is my first choice, but actually this is my second choice. With subset selection, they can't say that, which in a way is a bit frustrating. So let's say the spider question, a student might know, okay, spiders don't have wings and they have 8 legs. Right, 8 eyes or 10 ears, okay? Maybe they think, well, it makes more sense to have 8 eyes maybe than 10 ears. Maybe that biologically it sounds a bit more plausible, right? So they might want to put that as their first choice, and then they're kind of stuck with the 10 ears. Are they going to tick that as well, or are they going to gamble and not tick that? Okay. So in a way, this would be a student might want to answer in this way. Okay. So what we really want is partial ordering. So partial ordering means you can allow the students to answer in any way they like. So we haven't implemented this, but you could imagine. So we're still using the same questions. You haven't changed the questions. You've still got the same question bank. But now you're asking students to answer the question by saying, for each of the 4 answer options, A, B, C, D, indicate your belief in that option. Okay? With traditional, all the student can do is say, I believe it's A and not B or C or D. Okay? Or one of the other options. So a student doesn't have any other freedom of expression. It's freedom of expression. With subset selection, students can say, okay, I think it's A or B, but not C or D. Do you see what I mean? With partial ordering, you're giving much more freedom, and this is really I think when you look at a multiple choice question, the question and the 4 answers, you've got some belief in your mind about the rightness or wrongness of those 4 answers relative to the question. And really, we want to allow students to express their belief in all of those 4 answers. Do you see what I mean? We're inhibiting them by forcing traditional or by subset selection or by order of preference. You're limiting the range of responses that students can give. So, okay, this is just one point I should make, that we should distinguish between the test format and the marking scheme. So the test format is the instructions to test takers. So we need to tell the test takers, how are they going to answer this question? Is it subset selection, or is it order of preference, first choice, second choice, third choice, fourth choice, or is it sliders to indicate amount of belief in each of the 4 answers, okay? And then the other thing, of course, is the marking scheme. So we need a marking scheme, or marking rubric, to say, okay, for this response that a student has given, what mark do we award? Okay? And for subset selection, I showed you 2 different marking schemes. One was the +3 -1. The other one was the 1 or 0.5 or 0.33 or 0.25, depending on how the student has answered. Okay. This goes into more detail. I'm sorry, this text is small. There's actually other ways that students can answer questions as well. There's a thing called elimination testing. Maybe some of you have heard of elimination testing. On the next slide, there's a reference to a paper in 2015 that talks about this in more detail. So elimination testing, now you're saying to students, don't select what you think the answer is, select what you think are the wrong answers. Okay, so now you're asking students to tick the wrong answers. And the classic marking scheme for that is every time a student ticks a wrong answer successfully, they get 1 mark. But if they tick the right answer, saying, I think that's the wrong answer, they get penalized -3. So, some studies have shown students find that, that's a really harsh penalty, -3 for ticking the wrong thing. Anyway, that's elimination testing. It's just the mirror image of subset selection with the +3 -1. This is strict ordering. Okay, in this diagram, this axis shows the number of possible responses. So this is kind of the vocabulary, if you're thinking about the freedom of expression. With the traditional test format, there's 5. So a student can answer A, B, C, D, or leave it blank, skip. So that's 5 different answers. With subset selection, now a student can select any one or more of those. So each of these A, B, C, D could be ticked or not ticked. So you've got 2 to the power 4 combinations, 16 different combinations. Okay? Strict ordering, order of preference, where you're asking the students to say, what's your first choice, second choice, third choice, fourth choice? Well, that's 4 times 3 times 2 times 1, which is 24. And if we include skip as well, so we say to a student, if you've got no idea, leave it blank. So that makes 25 different responses. Okay? So a student has got, one of 25 different ways they can answer this question. With partial ordering, with the sliders, well, I couldn't even figure out how many. Maybe I didn't spend long enough trying to do that, but there's a much bigger vocabulary of responses that students can give you. And it's still from the same question. You haven't changed the questions. You've still got the same questions. You're just using these questions in a more imaginative way. And with the idea that the mark you get at the end is a more reliable assessment of what the student deserves. Okay, have I got time for this? I'm not sure. So this is just kind of a notation that shows you the vocabulary of responses. Not sure maybe I'll come back to that later if I've got time. Okay. So I've been talking about some different kinds of multiple choice test format. There are some other ones which are pretty well known. Maybe some of you know these very well. One is confidence-based tests that I've been seen used in medicine very frequently, medical education. So here's a question, and here are 4 answers. So now you're asking students to select one answer and also say how confident they are in that answer. High confidence, medium confidence, low confidence, and they get a mark accordingly. So, ideally you want a student to pick the right answer with high confidence. Okay? But if they pick the wrong answer with high confidence, thinking it's the right answer, you need to penalize them a lot. Whereas, can you see what I mean? So that's in training doctors or medical professionals, it's important for the test takers to have an idea of to what extent do they believe their own answer to this question. Okay? So that makes a lot of sense. Probabilistic tests, probabilistic tests, right. That's a generalization of, I went the wrong way. Sorry. Okay, so with a probabilistic test, each slider goes from 0 to 100. 0 to 100, okay? So now it's, the expression, putting all your eggs in one basket. So if a student thinks the answer is A, is confident of A, they can put A to 100 and B, C, D, 0, okay? But with the probabilistic testing, the thing is that these have got to add up to 100. So basically, they've got 100 eggs, and they're dividing those 100 eggs into the 4 pots, A, B, C, D, according to how much faith they've got in each of these 4 answers. Okay? And the mark they get depends on which answer was right, how many eggs did they put on that answer. Okay? So that's how probabilistic testing works. And that's a generalization of subset selection, because with subset selection, with the second marking scheme I was explaining. So that with subset selection, you've either got 100, 0, 0, 0, or you've got 50, 50, 0, 0, or you've got 33, 33, 33, 0, or you've got 25, 25, 25, 25. Okay, so that subset selection is a restricted form of this probabilistic testing. Okay, recently at my university, in England or the UK, the professional body that deals with solicitors, lawyers and solicitors, they're coming up with some new professional exams. So multiple choice tests, I'm not sure what kind of level of education you work in, but they're also used for professional exams. So really serious exams are multiple choice tests in industry, and usually traditional tests. Anyway, they're coming up with some new exams for people to qualify as lawyers and solicitors in the UK, and they're going to be partly traditional multiple choice tests. There's also role play, and there's also other kinds of assessment, but anyway, traditional multiple choice tests, and also extended matching questions. So maybe some of you have come across that. So an extended matching question is basically a multiple choice question, and here you've got, in this case, 13 different answers, okay? And this is from a medical test, so I just found this online when I was looking up the subject. So there's 13 different medical conditions, okay? And so the idea is the test taker would sort of read through this list of 13 and try to get that list in their heads, and then there are going to be a series of questions. And each question has some kind of scenario. An 82-year-old woman complains of severe pain, blah, blah, blah. Which of these 13 conditions do you think fits as a diagnosis for this scenario? Okay. So obviously that's very effective at eliminating the blind guesses. So a student who has got no idea, they've only got a 1 in 13 chance of getting the right answer. Okay. But most students, hopefully, will have some partial knowledge. And so most students will be able to say, well, many of these it can't possibly be, but still I can narrow it down to 2 or 3. you've still got the same problem then. They're forcing them to make a guess between those two or those three. So you've still got unreliable scores. So, this might be a good way of counteracting blind guessing, but it doesn't, as far as I can see, it doesn't really help counteracting the educated guessing. So the scores at the end are still going to be unreliable because you force students to make educated guesses. Okay. Of course, quality assurance is important, both pre-test. So if you're creating tests for summative purposes especially, it's important to get colleagues to look at those questions very carefully. And it's hard to create good quality questions. So peer inspection is important. And post-test, okay, it's important to analyze the students' responses. Okay? But there again, subset selection I find really helps because sometimes we might have some really good students in the class and they're getting most of the questions right, but maybe there's 2 or 3 questions which they're using subset selection and they're saying, I don't know whether it's this one or this one, and they tick them both. And they might do that over 2 or 3 questions. So that's really informative for me. That tells me that the student, these really good students, can't decide between these 2 answers on that question, right? If it was a traditional test, the only feedback I would get is, oh, the student got the right answer, oh, the student got the wrong answer. So it's more informative, subset selection is more informative in terms of analyzing the distracted choices. So that's another benefit for using it. Okay, one point I should have made, I must have skipped over the slide. So I've been talking a lot about the reliability of a test. And by reducing the guesswork, you're making the test scores more reliable. Okay? But of course, if a test has many questions, the more questions they are, the more reliable the test is going to be anyway. So the more questions you have in your test, the less you need to worry about this kind of stuff. But having said that, I'll just go back to this slide here. Okay. So there's a gap between, this gap is kind of indicating the guesswork. So the more questions you have in a test, the more reliable it is, but the lower the scores, the more likely it is that an element of those scores is going to be due to guesswork. Okay? So if you have a test where the pass mark is high, 80% or 90%, you don't need to worry so much about the unreliability or the guesswork. But if you have a low pass mark, like 40%, and especially if you don't have that many questions in a test, then I think you need to worry a lot about reliability. I think that's all. So there's some demo tests at the end. I showed you the I think we're okay for time, aren't we? 5 minutes, okay. Okay, so I showed you the Google form, all right? Let me show you a quiz slides test. So this is the software that we've created. So you create your test as a PowerPoint document, you upload the PowerPoint document, and it just magically prepares the test like this. The first slide is your welcome message slide. The last slide is your end slide. So in the PowerPoint document, you need those 2 extra slides. And so this one is answer until correct. Okay, so it's told straight away I got the right answer. It gave me 3 marks. Okay, let me choose the wrong one. Okay, so it's telling me no, it's the wrong answer. You can have another go. So there's many software platforms that do this kind of thing. And the marking scheme we've got for this is 3 marks if you get it right first time, 1 mark if you get it right second time, -1 if you get it right third time, because that's worse than blind guessing, or -3 if you're completely wrong. And you can also give up. So you could also say, I don't know what the right answer is, give up, and the system will tell you what the right answer is and give you a score of 0. So there's some links to 3 tests. We're redesigning the platform because this wasn't done in a very scalable way. So we can't have a large number of students all taking a test at the same time. So we've redesigned it, and I've given you a 3rd link to the thing that we're redesigning. And we're using our own students, actually, to write the software for that as well. I think that's all I wanted to say. So I welcome any questions. Thank you.